Welcome back to another video. Let's jump right into the topic of binomial distribution. As you already know, a Bernoulli process is an experiment or trial with only two possible outcomes: success, where random variable equals to 1, or failure, where random variable equals to 0. The probability of success is denoted as p, and the probability of failure is 1 minus p. If we repeat a Bernoulli process n times, we will have a binomial distribution. We can calculate the probability of observing exactly x successes and, as a result, n minus x failures, where each trial is independent, meaning the outcome of one trial does not affect the outcome of any other trial. The probability of observing exactly x successes in n Bernoulli trials is given by the binomial probability mass function, which is combination of x success out of n trials multiplied by probability of success to the power of x multiplied the probability of failure to the power of n minus x. The combination term accounts for the number of different ways we can arrange x successes in n trials. For example, if you toss a coin 3 times and want to know the probability of getting exactly 2 heads, the combination term would tell us there are 3 ways you can get 2 heads and 1 tail in 3 tosses. Probability of success to the power of x represents the probability of getting x successes. Since each success has a probability of p, you multiply p by itself, x times. Similarly, probability of failure to the power of n minus x represents the probability of getting n minus x failures. Since each failure has a probability of 1 minus p, you multiply 1 minus p by itself n minus x times. Intuitively, the mean of the binomial distribution is n times the mean of the Bernoulli distribution because you're adding up the mean number of successes from each of the n Bernoulli trials. Similarly, the variance of the binomial distribution is n times the variance of the Bernoulli distribution because you're adding up the individual variances of each of the n trials, and each trial's outcome is independent of the others. Thus, in both cases, you're summing the contributions of n independent trials, and this causes the mean and variance to scale by n. Here we are looking at 3 different binomial distribution. These plots the distribution of random variable x, which follows binomial distributions with probabilities of success of 0.1, 0.5, and 0.9. Although all 3 distributions have the same number of trials, 20, they show completely different behaviors due to their different probabilities of success. The plot on left is a binomial distribution with parameters 0.1 and 20. It has a mean of 2 and a variance of 1.8. Given the low probability of success, it makes sense that we only expect to observe 2 success on the long run and expect to observe many failures, hence the low variance. In the middle there is a binomial distribution with parameters 0.5 and 20. It has a mean of 10 and a variance of 5. Having a probability of success of 0.5, we should expect to win half of the trials on the long run, with the price of having a higher variance, 5. In the right there is a binomial distribution with parameters 0.9 and 20. It has a mean of 18 and a variance of 1.8. Given its high probability of success, we should expect the higher number winning in the trials and the low variance. Let's go over this example together. Suppose you were given a 10-question multiple-choice exam in which each question had 4 possible answers. If you had no idea what the course is about and had to guess at every question, what is the probability of getting a perfect score? You can pause the video here to take a moment and try answering this question on your own. This is a binomial distribution because there are a fixed number of trials, 10 questions, and each trial or question has 2 possible outcomes: correct success or incorrect failure. The probability of success, getting the correct answer, is the same for each question, which is 0.25. The trials, questions, are independent, meaning the outcome of one question does not affect the others. We can say that the number of correct answers, which we'll call x, follows a binomial distribution with n equaling to 10 trials or questions, and probability of success equaling to 0.25, the probability of a correct answer on each question. We want to find the probability of getting exactly 10 correct answers, which means the probability that x equals 10. This can be done using the binomial formula, which is combination of 10 out of 10 multiplied by 0.25 to the power of 10 multiplied by 0.75 to the power of 0, which is less than 1 in a million chances. Suppose it takes at least 7 correct answers out of 10 to pass the test. What is the probability of passing? Again, please pause the video here to take a moment and try answering this question on your own. To pass the test, you need to get at least 7 correct answers. This means we want to calculate the probability of getting 7, 8, 9, or 10 correct answers. We can calculate the probability of passing by summing up the probabilities of getting exactly 7 successes, 8 successes, 9 successes, and 10 successes. Alternatively, we can use the cumulative distribution function to subtract the probability of getting fewer than 7 correct answers from 1. Remember, one of the properties of a probability mass function is that the sum of the PMF over all possible values of the random variable must equal 1. We can take advantage of this property to find the probability of getting at least 7 correct answers by subtracting the cumulative probability for 6 correct answers from 1. Whether we choose to sum the individual PMF values for 7, 8, 9, and 10 successes or subtract the CDF for 6 from 1, the result will be the same. The probability of passing the test is approximately 0.0035, or about 1 in 286 chances. What score do you expect to get on the exam, on average? Again, please pause the video here to take a moment and try answering this question on your own. The expected successes in this binomial distribution is 10 multiplied by 0.25, which is 2.5. Suppose through some late-night studying you are able to now correctly eliminate 2 answers on each question. What is the probability of getting a perfect score? Again, please pause the video here to take a moment and try answering this question on your own. You are still taking a 10-question exam, and you need to calculate the probability of getting a perfect score, which means getting all 10 questions correct. The only difference is that the probability of success has increased to 0.5 due to your successful elimination of 2 of the answers in each question. We want to find the probability of getting exactly 10 correct answers, which means the probability that x equals 10. This can be done using the binomial formula, which is combination of 10 out of 10 multiplied by 0.5 to the power of 10 multiplied by 0.5 to the power of 0, which is still less than 1 in a million chances. After some late-night studying, you are able to now correctly eliminate 2 answers on each question. What is the probability of passing with a score of 7 or more? Or alternatively, what are the chances of passing the course? Again, please pause the video here to take a moment and try answering this question on your own. To pass the test, you need to get at least 7 correct answers. This means we want to calculate the probability of getting 7, 8, 9, or 10 correct answers. The only difference is that the probability of success has increased to 0.5 due to your successful elimination of 2 of the answers in each question. Whether we choose to sum the individual PMF values for 7, 8, 9, and 10 successes or subtract the CDF for 6 from 1, the result will be the same. The probability of passing the test is approximately 0.172, or about 1 in 6 chances. Here you can see how we can use Python to calculate binomial PMFs, CDFs, and visualize them. We can use the binomial function to model a binomial distribution. Here as an example, I have calculated the probability of answer all 10 questions correctly and passing the exams in the example, where we have successfully reduced the answers to 2 options per questions. Thank you for your attention, and see you in the next video.